All right, so you have your calculator. Let's go ahead, and here is, we've already talked about the calendar all the way through, and let's get started. As I told you guys, we'll be looking at some right triangle trig to start off with, so some geometry stuff. All this stuff you've already seen before. It should be nothing new to you that you haven't seen all the way through, especially the hypotenuse, the SOHCAHTOA, and all that stuff as well. So let's go and dive into example 1, okay? So let's find the exact value of the 6 trig functions of the angle theta. Now, what I do want you to focus on is when we talk about these angles, you got to remember, SOHCAHTOA is great. The problem is, SOHCAHTOA is all based upon a perspective of theta, which means I have to look at the angle of theta. It's not by looking at the situation of the triangle, it's looking at the angle itself. So the angle I circled, that's your SOHCAHTOA. So what I'm trying to say is that this theta, its measurement and all of its SOHCAHTOA would be different than that theta. Okay? So as you can tell, this theta, it's already been labeled as opposite over here, but if we use the theta on top, that would be its opposite. So please note that when we talk about SOHCAHTOA, it's all perspective of where theta is or where the angle is. Okay? And so we go through, the first thing we'll talk about is, so I'll go ahead and write it out here. What I like to do. That's kind of the way I like to write SOHCAHTOA, just because it already looks like a ratio. And that's what you'll be putting your answers in. So the first one is going to be, well, first thing is we need to go ahead and figure out what is opposite to begin with. And so we go through and talk about Pythagorean theorem, right? You guys know this one. This is probably one of the most popular formulas there is. If I usually start it, most people finish it. A squared plus B squared, what? Equals C squared. There you go. So that's what we'll go ahead and dive into first. And we always know that C is going to be considered your hypotenuse. So another way to write it would be also, if you want to write it in SOHCAHTOA form, O squared plus A squared equals H squared. And for the most part, I see students actually gravitate. When we talk about right triangle trig, I see students more gravitate to this because this falls with what you're labeling everything by. So we go through, let's go ahead. We already have the opposite labeled. What's the length 3? What's that side considered when we're relative to theta? Adjacent. And then what is 5? Hypotenuse. So there you go. So let's go ahead and fill in our work here and solve for it. So we know that opposite, we got to figure that one out. That's still O squared plus 3 squared equals our hypotenuse squared here. Of course, when we're solving, and so you find out it's 4. Or if you remember any of your Pythagorean triples, you know 3, 4, 5 is a Pythagorean triple. The length 3, 4, and 5 always go together in all versions of those. All right. So first thing is now we know it's 4. So now we can dive into all of our 6 trig functions. So first one we go into is going to be our sine. So the sine of theta is the ratio of opposite over hypotenuse. So cosine of theta is adjacent over hypotenuse, and tangent is opposite over adjacent. Now moving into their inverse. So cosecant of theta is just the inverse of 4/5. Well, it's not 4/5. Secant of theta is the inverse of 3/5. And then cotangent is the inverse of 4/3. Now guys, you got to remember when we talk about inverse, that word will be used quite often. When we talk about inverse, it means taking the fraction, just flipping it. That's all it means. And we talk about this for the next couple of months. So when I say inverse of some ratio, it just means flip it over. That's it. Okay? Now, you do have to be careful. When we talk about secant and cosecant and cotangent, those are the inverse of these trig functions. Okay? Please know that. These are the inverse of this. So what I might do is, underneath, I know you guys have seen this, but I'm going to go ahead and write it. It's the inverse of those trig functions. All right? Any questions so far, guys? Should be all basic review stuff. All right, let's move on. So it goes on to say two acute angles are complementary if their sum is a right angle. You all know that from geometry. Because the sum of the angles of any triangle is 180, it follows that for a right triangle, the two acute angles are complementary. Basically what it says is, hey, we know that the sum of the three angles in a triangle will always add up to what? 180. If we're talking about the one thing today, right triangle trig, of those three, one of them is a right angle, which is how many degrees? Exactly. So it's 90, which means the other two have to add up to what? 90 as well. So that's called complementary. So it goes on to say, hey, if I have a right triangle, there's a right triangle, and I have the other triangle is 60, what's the final angle? Length? 30, because 60 and 30 have to add up to 90. Don't think of it as all three of them have to add up to 180. That's just extra work. Just know two of them that are not the right angles have to add up to 90. And that's just by definition, that's what they talk about here. So in this case, it would be that A and B would have to add up to 90, or A and B are complementary. So it goes on again, find the sine of B, because this is going to talk about perspective. So looking at the perspective of angle B here, what is the sine of it? Using the letters A, B, and C. So it's what? B over A. Good, James. B over A. Let's move across. Let's look at the cosine of A. So we're going to use the perspective again now of up here. So what's the cosine of A using the letters A, B, and C?
A over C.
Yes. Try that. Let's try that again. Did I say B over A?
B over C.
Did you say B over C, James?
Yeah.
You did? Did I just not listen to you? Okay, sorry, buddy. B over C, which means that, what's the cosine of A? Well, if we're looking at the top, what side is adjacent to the angle A? Look at, yes, B. Over, what is the hypotenuse? C. What do you notice about both of those? They're the same. If I take the sine of one angle, it's going to equal the cosine of the other angle. Now notice, when I say one angle, I am always going to treat right triangle trig, guys, as there's only two angles. Because we know the third is 90 degrees. I'm not going to discuss that at all. I'm only going to talk about one and the other. So, the sine of one angle equals the cosine of the other. Because it goes back to what I said earlier. Perspective, all about perspective. So if I'm looking from angle B, the opposite is side B. But if I'm looking from angle A, the side adjacent is also B. All about perspective here, guys. Okay, let's go and look at the next one. Tangent tangent of B. And so tangent of B is going to be, what, opposite over adjacent? And what's opposite for this one, for B? B over what's adjacent? A. What about cotangent of A? Cotangent of A, again, remember, cotangent is going to be adjacent over opposite. Adjacent over opposite. So look at angle A. What is adjacent to angle A? Over opposite, which is? What do you notice about tangent and cotangent of opposite angles? Yeah, and that whole area, guys, is basically what I've already discussed, which is talking about, just notice that these are all the same because you're going from one perspective to the other. You're going from one perspective to the other, and that's why they're all the same. All right, so let's go ahead and look at something you probably haven't seen, but we'll go ahead and discuss it. And this, what we just did, kind of brings us into this last part here. And what it talks about is a complementary angle theorem. Oh, I guess I should fill in the blank. Because of these relationships, the functions sine and cosine, tangent, cotangent, secant, and cosecant are called complementary. Complementary angles. So basically what it's saying is that these relationships of functions sine, cosine, secant, because of those right there, so the sine of B and the cosine of A are considered complementary angles because they both add up to 90. So it leads us to here. Complementary angles are cofunctions of complementary angles are equal to each other. So if you look here, the sine of 30 is equal to the cosine of 60. Because the idea is, okay, this is one angle and that's the other angle. And as we just discussed up here, guys, the sine of one would equal the cosine of the other. Do note, these two angles here add up to 90 degrees. Do you see that? That's the reason why this equation works. That's the reason why when we say sine of one angle equals cosine of the other, same thing goes true here. And then over here, secant and cosecant, if you remember, guys, oops. Just to write it down for good measure, you probably already know it by now, but I'm going to go and write it down anyways. Recall, this is the inverse of cosine, this is the inverse of sine, so that's why they're equal to each other. And so those are complementary angle theorems. Which tells us this, guys. If I take, using algebra right here in this equation, if I move them all to the same side, what would that equal? Right? If they're equal to each other, then guess what the difference is equal to? 0. If x is equal to x, what's x minus x? 0. 2 is equal to 2, then 2 minus 2 is 0. Same goes true here, which tells us not only are they going to be equal to each other, but also their differences are equal to 0. And same is true all the way across, but I'm not going to do those. Complementary angle theorem. So let's dive into some examples. Using the complementary angle theorem, let's find the following. Well, we do know that 62 degrees has a complementary angle. And what is a complementary angle to 62 degrees? 62 plus what equals 90? 28. And you use its complementary function. So we go on to the next one. 30 plus what equals 90? 60. And we use its complementary angle. Or function, sorry. And of course, as I showed you just a while ago before we moved on to this one, if you notice sine of 56 minus the cosine of 34, well, what's true about both of those angles, 56 and 34? They add up to 90, or they're complementary. And we know sine and cosine are two math functions that work for complementary angle theorem. Therefore, what's the answer to this? 0. 0. And one more way of looking at it as well is what if we divided the two things? Remember, these two things are equal to each other. So what is it when we divide two things that are equal to each other? What do you get? 1. Questions about complementary angle theorem? Now remember, sine goes with cosine, tangent goes with cotangent, secant goes with cosecant. That's the only ones that all work. There's only 3 sets. Okay? Secant would not go with cotangent. Sine would not go with tangent. Okay, those don't work together because they're not complementary. Okay? Do know that those 3 sets there always work together. That's the only way they work. So be careful with that. All right, here we go. Using triangle below, find out if B is equal to 2. They've already labeled it for us. Angle A is equal to 40 degrees. That's labeled for us. It says find AC and angle B. So let's go ahead and find what we get there. So I'm going to use always, guys, always use angles that are given to you in the problem. Always try to use the information that's given to you. Try not to use the information that you have calculated. Why I'm saying this is because I've seen students go ahead and find out that that is 50 degrees, which it is, but then they'll use that. And they'll say, oh, I'm going to go ahead and use tangent of B to do this. Well, even though you're certainly right, because it's a simple addition-subtraction problem, it's always safe to use information that's given to you in the problem and not information that you have calculated. You might be off by a decimal, which makes everything else follow wrong. You may have done a simple typo and miscalculated it. And now everything else is wrong there as well. So use information that's given to you, and so we're going to use 40. So let's think about it. The only thing that's given to us, if we're using 40 degrees as our perspective, what is 2 considered when we're looking at 40? Adjacent. I know this is going to throw some off, that's why I'm using a capital letter, but what is going to be considered, you know what? I'll do that. What is considered, what's A considered in relative to 40 degrees? Opposite. And then finally, what is C considered? Nice thing about C is, it doesn't matter what point of view you're looking at or what perspective, it's always the hypotenuse, right? No matter what, because it's always opposite of 90 degrees. So let's use this. So we go through. First thing we need to figure out is, well, let's find the hypotenuse first. So which one of these trig function uses A and H? So cosine of 40 degrees equals the ratio 2 over, what letter do they use? C. And so let's go ahead and figure that out. How do we solve this for C, guys? Be careful, multiply by 2. If you multiply both sides by 2, this is what we'll get. Is that what you want? Okay. She's on the right track, though. You do have to do something like that. What I always... Matthew? Divide by C, multiply by C by both sides? Okay. So, go ahead, Lauren.
Could you divide 2 by both sides?
Right. So, what we'll do is this. Let's go ahead and take your step, multiply both sides by C, because, guys, when we talk about fractions and we want to get rid of them, we always multiply everything by the denominator, right? If I have 1/2, 1 over 2, and I want to get rid of 2, the denominator, just multiply times 2, and it's gone. In this case, we'll multiply times c. So you multiply both sides by c. It goes away. You're left with c times the cosine of 40 degrees, bless you, is equal to 2. And then just like what Lauren said, what we end up having to do is this, divide by cosine of 40. And so now you end up with this ratio. C is equal to the 2 over 40 degrees. Now, in doing this, in your calculator, guys, make sure that you have your calculator in what mode? In degree. Why degree mode? Because we're looking at degrees. Because it's 40 degrees, not 40 radians. So when the question is in degrees, make sure your calculator is in degree mode. Now what's nice is the calculator will usually give you an answer the way you put in the question. So what we've been working on, and I always like to do, is always like to put my calculator in alpha y equals for fractions, okay? When I'm doing any type of math functions or any type of math with fractions in my calculator, I do alpha y equals. Because the calculator will give me a fraction answer if it can. So whatever input you put into the calculator, you get the same type of output. So let me show you something, guys. If you go to... If you go to second apps, it's about in the middle of the, it's next to math, underneath the x variable. If you do second apps, you notice the very first thing, option number 1, is the degree symbol. Do you see that? So let me show you something. Now you know where it's at. Quit out of this and go to the home screen. Let's do alpha y equals 2, press the down arrow, cosine, and go to second apps and press, I'm sorry, got to put degrees in first. 40, and then second apps, degrees. So it should look like 2 over cosine of 40 degrees. Did you find it?
No, I didn't. I didn't.
Correct. So alpha y equals enter 2 over cosine. You need to round 3 decimal places. Okay, that's the expectation when you go through to answer these, round 3 decimal places. All right, so we found C. That's taken care of. Let's go ahead and find A. And so now looking at, again, the perspective of 40 degrees. They give us adjacent. What do we need to find? Opposite. So what trig function uses adjacent and opposite only? Tangent. Tangent. SOHCAHTOA, right? SOHCAHTOA. So the tangent of 40 degrees equals, of course, if you look at it, and I'll go ahead and write it again up here, guys. You notice tangent is opposite over adjacent. So in this case, our opposite is A and our adjacent is 2. Now, notice, unlike the previous work we just did, this one has the variable as a numerator. How do we get rid of this one now? Elena? This one we multiply by 2, exactly. When the 2 is on the bottom, you can get rid of it. Gone. Always like it when it's set up this way. That's all we do is put that in our calculator. 2 tangent 40 degrees. 1.678 is equal to A. And then find the very last thing, which sometimes I do this backwards. Usually some people like to find the angle first, I like to find it last, that way I'm not tempted to use it in any of my calculations. So now we just go ahead and do that. And of course, by now you guys have seen this so often, we know that 40 degrees and angle B add up to what, guys? Yep. There you go. Pretty straightforward, right? Right triangle trig. All right, let's move on to the next example, number 4. Use triangle below. If A is 3, B is 2, find C, A, and B. All right, so with this one, here's what we have. They've given us 2 sides, and they want us to find the other 2 angles and the hypotenuse. What would you like to dive into first, guys? The angles? I wouldn't have gone that way. Which one did you? Where did you say?
Oh, I said no.
You said none. Avery said she don't even do this. Throw it away. Sam agrees. He woke up for that. Thanks, Sam. To me, and I mean it's whatever you want to do. I like to get the side done first, because I know that one's going to be the straightforward one, right? So we'll use Pythagorean theorem here. Unfortunately, it's not a Pythagorean triple. So 2 squared plus 3 squared equals c squared. 4 plus 9, 13. And we leave it like that. Yes, we're allowed to use calculators. However, we're going to leave it as the square root of 13. All right, so there we go. There's that. So this, I'll go ahead and write in that we found out it's square root of 13. And now let's go ahead and find those other 2 angles. James, which one do you want to find first, A or B? B first, all right. So we're going to go here. What trig function, guys, will we use here? Why?
Opposite over
Good. That's right. James noticed that what's given to us, the 2 and 3, not the one that's calculated, we're going to use what's given to us, 2 and 3, from looking at the point of view of angle B, 2 is opposite, and 3 is adjacent. And so he uses tangents. Good job, James. I don't want to use red. All right. So now we go and dive into this one. So what do we do to find this answer? You remember? No. Okay, this again is considered an inverse function as well. But you got to be careful here, guys. This is the inverse of not the tan function, it's the inverse of the whole ratio. So what you have to do is that. Second tan. Remember, tangent gives you straight up sine, cosine, tangent. If you put in your calculator, gives you a length of a side. If you use second in any of those trig functions, it gives you the angle. Now, in this case, unfortunately, wish I could help me on this one. This one, if you use, because here's the answer, is going to be an angle. Do you all agree? Unfortunately, guys, you have to make sure your calculator's in degree mode for this. For sure. There's no way around to it. So go to mode. I haven't changed mine over, but here we go. So we're in degree mode. So now we do second tangent of 2/3. And you get 33.691. Looks like a 6. And now at this point, you know, you could say, hey, take that answer and subtract it from 90, and there's it is. But don't want to do that. So what do we do now? What do you suggest we do now? If I'm looking at angle A, now what's the perspective of what we're looking at? What's 3 and 2? What's 3? And 2 is going to be adjacent. So we're still going to use tangent, correct? Except the tangent will look a little bit different. Oops. Since we're at a different perspective, the fraction is now flipped. And so we do the same steps, inverse tangent. Make sure our calculator is in degree mode. And you end up with, what, 56.310? Good? Okay. Still reviewing, right? Solve the right triangle when you find out that the angle A is 34.2. Now, the good thing about this, guys, is you can label this any way you want. I think some teachers like to start here, go around. You can do that. If you want to do this and go around, it doesn't matter at all. One thing you do need to know is they tell you angle C is 90 degrees. So I do need to know that C definitely needs to be the right triangle, the right angle. For sure. So they go on and say 34.2 is angle A, so that's 34.2. And it tells you side B is 19.4. Well, let's solve the rest. So we have two sides and an angle we got to finish up with. Yes, James?
So it doesn't matter why you put 19.4.
Good question. It always has to be, remember, B is going to be the opposite of angle B. Side B will be the opposite of angle B. I didn't say that, but yeah. So that means that side A over here is the opposite of angle A. So yes, it would make a difference where that is, for sure. All right, so the first thing I want to do is, I'll go ahead and take care of the one easy problem. What is angle B? I think I heard someone say it. 55.8. And that's all I'm going to do with that. That's all I'm going to do with angle B. I'm just going to find it and then move on to the next problem. Now let's figure out side A. So in order to figure out side A, what's given to us is 34.2 and also 19.4. So in relation to 34.2, or angle A, what is side A and what is side B? Opposite and adjacent. What trig function uses opposite and adjacent? Tangent. All right? Got lucky on this one again. The variable is a numerator, which means that the number, the value we have, is a denominator. Which is great because what do we do to solve this one? Multiply it by the denominator, by 19.4. So 19.4. Tangent of 34.2. You get 13.184. And then finally, let's go ahead and figure out the last piece of this triangle. Side C. Again, using angle A that's given to us and using side B that's given to us, what is C considered first off? Hypotenuse. Very good. So if it's a hypotenuse, what trig function uses adjacent and a hypotenuse? Cosine. Cosine of, what is it, 34.2 equals adjacent over the hypotenuse. And so we go through, well, C's on bottom here, so multiply both sides by C. Ends up being over here, and then divide by cosine of 34.2. So you end up with your hypotenuse being 23.456. Yes, Ms.
Are
Wayne?
you able to take the sign of like angle C if both its values are like the same? Because its opposite is like also the hypotenuse, right?
That is true. So what did you say? Take the sine of angle C, which would be 90 degrees, right? Because angle C is 90 degrees, correct? So if you take the sine of, okay, if you're looking from here, if you take the sine of this, what's opposite? Right? And then it's over the hypotenuse, which is the same thing. So you'd just be getting 1. That's what would happen there on that one. So yeah, I like the idea of looking at a different perspective, saying, hey, can we just do it here since it's opposite in this? Problem is whatever's opposite will be the exact. And then adjacent ends up looking really weird because which one is adjacent? That's where we start to get really confusing there. And actually the sine of 90 degrees is 0 if you put in your calculator. But yeah, that's it's an interesting way to look at a different perspective, but unfortunately you can't find the sine of 90 because it's always going to be 1 every time. Because, again, opposite and hypotenuse are the same thing when you're looking from the right triangle perspective, right? I never had that question before. That's pretty good. All right, let's go ahead and do some application problems here, guys. Surveyor can measure the width of a river by setting up a transit at a point C. On one side of the river, taking a siding of a point A on the other side of the river, refer to figure 10. After turning through an angle 9 degrees at C, surveyor walks a distance of 200 meters. I mean, everything they're saying in this problem, they're just giving you an illustration for it, okay? All it wants to do is, what is the width of the river rounded to the nearest meter? So it just needs to know what B is, okay? And so from here, we go through and say, all right, well, they gave us angle B. What else did they give us? Side A. What is side A in relation to angle B? Adjacent. Good. What are we looking for relative to angle B? Opposites. So what trig function uses adjacent and opposite? Tangent. We have opposite, which is B, over adjacent, which is 200. This one's 1 multiplication and done, right? Oh, nearest meter, right? Is that what it wanted us to round it to? Better follow instructions. So the width of the river is 73 meters across. All right. Next one. This gets some people a lot. Come on. Angle of elevation and angle of depression. You got to remember, angle of elevation, guys, is always, and depression is always by the point of view from your line of sight. So if I'm to look straight out, there's an imaginary line coming straight from my eyes all the way out. And from there, if I look down to this desk, it's an angle of depression. So from here to here is the angle of depression because it goes down from where my straight line of sight is, right? If I look up to the ceiling, well, now I'm looking at an angle of elevation because I'm looking up from where I'm looking straight out as, okay? Be very careful with that. When I make that illustration, it's pretty simple to see. But when we get in some problems, it gets pretty crazy sometimes. So, straight trail leads from the Alpine Hotel, elevation 8,000 feet. There's the elevation already, 8,000 feet off the ground. To a scenic overlook, elevation 11,100 feet. The length of the trail is 14,100 feet. What is the inclination grade of the trail? That is, what is the angle B of it? So they want to know what this is here. And they're giving you all this information. Okay? What they're asking you to find is very simple, the angle of elevation. So, well, in respective to laying on the ground, but we're not going to do that. We'll talk about 11 meters there. So let's go ahead and fill everything is in here. So they gave us opposite. And they've given us what else? Hypotenuse. So what trig function uses opposites and hypotenuse? Sine. So, in order to find angle, what do we have to do again, guys? Yes, inverse sine. Again, making sure your calculator is in degree mode. Second, sine alpha y equals 3,100 over 14,100. And you get that angle being, does it say round to what? Doesn't say to round to anything, does it? Okay. We'll just do 2 decimal places. So your angle of inclination from the trail, once you get on the trail, if you start to go up, that is a grade. Some people call it a grade. But it's a grade, inclination grade of 12.70 degrees. All right, I guess I jumped ahead earlier talking about angle of elevation and angle of depression. So again, talking about your line of sight. This here is angle of elevation because it's up. And of course, when you're standing on top of something and looking down, that's your angle of depression. And of course, as we always talked about, guys, what's the relationship between angle of depression and angle of elevation? They're equal to each other. So, what I'm trying to say is that, if you think about it, if someone is standing on top of a building and looking down to you, the degrees you have to look up to see the person is the exact same degrees that they have to look down to see you. All related to line of sight, straight in front of you, okay? So when you're standing up here and you're down here, this person looking up there is the same angle as that person looking down there. all the way through. So they match and they equal each other. So make sure we know that. All right. So let's look at the example 8 using that. Meteorologists find the height of cloud using an instrument called a ceilometer. A ceilometer consists of a light projector that directs a vertical light beam up into the cloud base and a light detector that scans the cloud to detect the light beam. See Figure 13A. On December 13, 2011, at Midway Airport in Chicago, a ceilometer, I don't know how you're supposed to say it, was employed to find the height of the cloud covering. It was set up with its light detector 300 feet from its light projector. So that's 300 feet. It goes on to say, if the angle of elevation from the light detector to the base of the cloud was 75 degrees, what is the height of the cloud covering? So, and I know they do another illustration off to the right, but I wanted to write it onto the picture to read it through and critically mark it through. Okay, so it says, what's the height of the cloud covering? So we need to figure this one out here. Well, this one's pretty straightforward, right? I mean, we've already dealt with this stuff already. We've been doing it all morning long. So according to 75 degrees, what is 300 feet? Adjacent. Good. And what is what we're looking for? H, opposite. What trig function uses opposite and adjacent? Tangent. And so you end up saying 300 and so you find out that the height from the light beam is 1,119. Does it say to round to anything? It does not. 0.62 feet. Is it feet? It is feet. So what's nice is, for the most part, they'll give you these illustrations, and then sometimes they'll give you what's everything filled in as well. But don't always rely on it. Sometimes you have to draw your own picture, okay? Okay, so next one. This is new. All right, this one, sometimes some people struggle seeing what's going on here. So adorning the top of the Board of Trade building in Chicago is a statue of Ceres, the Roman goddess of wheat. From street level, 2 observations are taken 400 feet from the center of the building. The angle of elevation to the base of the statue is found to be 51.1 degrees. The angle of elevation to the top of it is 56.5. So you're standing, you measure to their feet, then you measure to her height what your angles are. So that's why you see 2 dashed lines coming out of the same spot 400 feet away. The first one deals with the feet, the second one deals with to the top of the head. What is the height of the statue? So we need to figure out what the height of that statue is. So let me go ahead and zoom this out, or zoom this in a little bit so you can see a little bit big picture of what's going on. This is 400 feet. You have your first observation that is 51 degrees. First one's 55.1. Then you do it again, and you see to the top, which to the top is 56.5. But we need to figure out what is this distance right there. Any ideas? Yes, Matthew.
Subtract the height of the building from the height. You find out how tall the building is and subtract that from the height of the statue.
Top of the head, yeah. Find the height from the floor to her feet first. Bless you.
Thank you.
Then find the height from the floor to the top of her head. and subtract the 2. That's exactly right. Good, Matthew. So, let's go ahead and figure out, first one, looking at this triangle right here, let's figure out what y is. Okay, guys? That will be the distance from the floor to her feet. So, we do that, going through it all over again. But basically, according to 55.1, 400 is adjacent, opposite, or hypotenuse. Adjacent. Y is considered what? Hypotenuse or opposite? Opposite. And so what trig function are we using, guys? Tangent. 55.1 is equal to y, because we need to find that, over 400. Typo. All right, 573.387 feet. So, from the floor to the bottom of her feet is 573.387 feet. Keep going. What is it from the floor to the top of her head? So now we're going to find this triangle here. We're going to find not x. We're going to find z. Do you see that? Trying to use different colors to help you see different triangles there. Think about it. We have 3 triangles here. Do you see them? The 55-degree one, which is shorter. The 56.5, which is the bigger one, all the way through. And then there's a small triangle right here. But we don't really focus on that one very much. We're just going to find out what that length is just by subtracting it. All right, so finding z. Nice thing about this is 400 with relation to 56.5 is what? Adjacent, opposite, or hypotenuse? Adjacent is the same as it was the other one, right? Just so happens both angles are in the same spot, which is nice because that means our adjacent and opposite are all the same. So basically, I don't really have to really change much, except maybe move this to there now because it's all of z. The whole entire length is opposite. So what's nice is we still use the same trig functions, don't we, guys? So the tan of 56.5 is equal to, in this case, it's z over 400. Multiply both sides by 400. Which basically means I can copy and paste from my previous work, change 55.1 to 56.5, and I get what z is. All right. And it should be bigger, right? Should z be bigger than y? Yeah. Because the angles are bigger, which means the distance between my 2 fingers here on my right hand and my left hand, as this starts to get wider and wider, what do you notice about the distance between my fingers? Larger and larger. Exactly. As the angle gets larger, your distance of the opposite side gets larger. Okay. So then we do exactly what Matthew said earlier. To find the distance, so x is equal to z minus y, or 604.334 minus 573.387. And you get so the height of the statue is 30.948 feet. Questions, guys?